Welcome to FMSP Online Revision. This session is for AQA M1. We're looking at question 6 from June 2010, which is about connected particles. So if we start by looking at the question, it's quite a long question, so we'll just see what all we have to do. We've got two particles A and B. A has mass 12 kilograms, B has mass 8 kilograms. They're connected by a light, inextensible string. Now just be aware of these words. Light means that you can ignore any mass of the string. Inextensible means it's not stretching. And we're told that that passes over a smooth fixed peg. So the fact that the word smooth is there means we don't need to worry about any friction. And we have a diagram there that shows us the situation. So the particles are released from rest and move vertically. Assume that there is no air resistance. So quite a few parts to this question, but first of all we're asked to form two equations of motion, show that the magnitude of the acceleration of each particle is 1.96 meters per second squared. And once we've done that, we're asked to find the tension in the string. And then in part C it says that after the particles have been moving for 2 seconds, both particles are at a height of 4 meters above the horizontal surface. And when they're in this position, the string breaks. So we've got to find the speed of the particle A when the string breaks, find the speed of the particle A when it hits the surface, and then also the last part, find the time that it takes for particle B to reach the surface after the string breaks, assuming that particle B does not hit the peg. So let's have a look at how we're going to do this. So we first of all need to have a nice clear diagram. So let's think about the diagram. So we have a mass of 12 kilograms, so that's going to give us a weight of 12g, and then there will be tension acting upwards, we call that T, and then a mass of 8 kilograms, so a weight of 8g, and again there's tension which will be acting upwards. It's a smooth peg, the tension will be the same on either side of the peg. It's next what we need to think about is what direction the motion is going to take, and notice we've got a heavier particle over on this side, so the acceleration is going to be in that direction. So it's a good idea always to think about that and mark it on your diagram. So in part A then, so we'll take each particle in turn because it says by forming two equations. So one of those equations will be for particle A and the other will be for particle B. So particle A is going to move downwards, so we need the resultant force. So we're going to be using F equals ma, Newton's second law. So F is the resultant force. So there's a force of 12g acting downwards and a force of T acting upwards. So the resultant force downwards is 12g minus T, and that will be equal to the mass 12 times the acceleration. And then we can do a similar thing for particle B, but remember particle B is moving upwards, so T is the upward force and 8g is acting downwards, so the resultant force in that case is going to be T minus 8g, which will be equal to mass times acceleration, which is 8a. So what we're going to do now, notice that we've got a minus t there, negative t there, and a t plus here. So adding those two equations, hopefully you can see that the t's are going to cancel out. You're going to get 12g minus 8g, which is 4g, and 12a plus 8a is 20a. So that means that A is going to be equal to 1.96. 4g, remember, g is 9.8, so 4g will be 39.2. Divide that by 20 and you'll get A equals 1.96 meters per second squared. So that is part A, and then in part B, which we could put in here at the bottom, we're asked to find the tension in the string. So now notice in either of these equations we now know what the acceleration is, so it doesn't matter which one we use. I'm going to, if we call that 1 and that 2, I'm going to use equation 2. And so I'm going to substitute A equals 1.96 into equation 2. So I end up with T equals 8G, 8 times 9.8, plus 8A, which will be 8 times 1.96. And if you work that out, it comes to 94.08, which we would normally give to 3 significant figures and put in the unit of force, which is a Newton. So that's part A and B. Now at this stage, since it's quite a long question, I will actually just look at the marks for those two parts. So 5 marks for part A. So you got a method mark and an accuracy mark for writing down that the Newton's law, second law, for particle A, and similarly a method mark and an accuracy mark for doing it for particle B, and then adding the equations to find A gave you another accuracy mark. So that was where the 5 marks came from. And then in part B there was a method mark for substituting correctly into one of the equations the value of A, and then an accuracy mark for giving our answer of 94.1 newtons. So that 7 marks in total for that question, or that part of the question. Let's move on to part C now. So in part C it says that after the particles have been moving for 2 seconds, they're both at a height of 4 meters. So I've drawn a diagram here, so they're both at the same height. When the particles are in this position, the string breaks. And we're asked to find the speed of the particle A. So don't forget, we know from the very beginning that the whole system was released from rest. So that told us that the initial speed u was equal to 0. We've just found, when we did part A, that the acceleration of this system was 1.96, and what we need to do is we want to find the speed of the particle when the string breaks. So that was after 2 seconds, so we need to find v there. So we're going to use v equals u plus at. That's the equation we need, because that's the one that connects the information we have. So substituting in, v is equal to u is 0, a is 1.96, and t is equal to 2. So after 2 seconds, the speed of particle A will be 3.92 meters per second. So that's part 1. In part 2, we're asked to find the speed of the particle A when it hits the surface. So now we're thinking about this stage here, where particle A is 4 meters above the horizontal surface. We now know it has a speed of u, which would be 3.92. That's its initial speed. The string has broken, so there's no tension now, so the only acceleration that we have is due to gravity. Now that will act downwards, so I'm taking the downward direction here to be positive. Just as I should say I did over here, I took the downward direction to be positive. And since the particle is travelling downwards and acceleration is acting downwards, then that is probably the easiest thing to do. And the displacement when all this happened was 4. So we were told that it was 4 meters above the horizontal surface, and what we now need to do is we now need to find v. So we know u, a and s. We're asked to find v, so the equation we want to use this time is v squared equals u squared plus 2as. That is the equation that connects all that information. So if we substitute in, v squared will be equal to u squared, 3.92 squared, plus 2as, so that's plus 2 times 9.8 times s, which is 4. That turns out to be 93.76 and a bit more, 76, and always better just to keep these numbers in your calculator. So that implies, if we take the square root, that v is equal to 9.68 meters per second. And again, I've given the answer there to 3 significant figures. So that is the speed of the particle when A hits the surface. So the important thing there to realise is once the string breaks, the acceleration will just be due to gravity. So let's have a look at part 3 then. It says, find the time it takes for particle B to reach the surface after the string breaks. So particle B, remember, when the string breaks, was also 4 meters above the horizontal surface. But of course B was travelling upwards, if you remember, when all this happened. If you go back to the original diagram, you'll remember that B was travelling upwards, as we can see here, and A was travelling downwards. So B is travelling upwards. So let's think about what's happening. So that means that it's going to travel up here somewhere is the peg that we had. So it's going to travel up. It doesn't hit the peg, so it doesn't get as far as the peg. And then it's going to come back down. So on the basis that it's travelling upwards, I'm going to take upwards to be positive, which means that S will be -4. U, it's travelling up. Now be aware that it will be travelling at the same speed as A. If you remember, when the string broke, we found that the speed of A was 3.92. And it's important to realise that the speed of B will be the same. But it is now travelling upwards. So that is going to be 9.8. And T is what we're asked to find. And acceleration then is going to be negative if we're taking U to be positive and upwards to be positive. So this time we want to find the time. So the equation we need is S equals ut plus a half at squared. So -4 is equal to ut, so that will be 3.92t minus 4.9 a half a t squared. So rearranging that, we have a quadratic formula, 4.9t squared minus 3.92 t, that's taking everything over, minus 4 equals 0. And so we need a quadratic formula now to solve that, and because it won't factorise, so you do need to substitute that into a quadratic formula. And if you do that, you end up with t equals 3.92, so that's minus b, so negative 3.92, plus or minus the square root of b squared, which will be 3.92 squared, minus 4ac, which is minus 4, times a, which is 4.9, times c, which is -4. So you just need to do that quite carefully. I'm not going to go through all that working because you'll be able to use your calculators to do that, and it's over 2a, which is 9.8. Now if you do that and work it all out, then you'll get two answers, as you would expect with a quadratic. One is 1.39 to three significant figures, or alternatively t equals negative 0.588. Now of course the time, a negative time, is not going to be relevant, so the time we want is 1.39, well I'll put that t equals 1.39 seconds. So quite a bit of working there, but it mainly is just based on this quadratic formula that you just need to check. So let's go back, as we need to look at the other parts and just see how the marks were awarded for that question, for part C. So the speed of the particle, first of all. So the speed of the particle, you just had 2 marks for the question. So there was a method mark here for substituting in using v equals u plus at, and an accuracy mark for getting a correct answer of 3.92. And here, a similar sort of thing, you have 3 marks. There was a method mark for using v squared equals u squared plus 2as, and an accuracy mark which was a follow-through mark. So if you had made a mistake with one of these, so you had got 3.92 incorrect or something, as long as you did this bit using your answer, you did get a follow-through mark. And again here, another accuracy mark which was also follow-through. So if we just look at part 3, in part 3 we would have 5 marks for this question. So we had 1 mark, a method mark, for getting a quadratic equation, and an accuracy mark for getting all the terms, 2 accuracy marks in fact, for getting all the terms of your quadratic correct. So that's at this stage here. And then a method mark which was dependent on your method mark up here, on this method mark, for solving your quadratic equation, and then an accuracy mark for getting it correct, 1.39. So quite a lot of marks for that question, so it is really worth going through that carefully. So 17 marks altogether. So don't forget that if you want to access further revision videos, then you can go to the FMSP website and follow the link to online revision.